Myself Vidya Chitre. I'll be taking the lecture on database management system, PBL, and the experiment we'll be considering here is gradebook preparation. So for any PBL experiment or for any database management experiment, for starting with it, we need to understand what is exactly the problem statement. Then from the problem statement, we need to identify what are the different entities, what are the different parameters based on it, what are the different relations, how the different entities are related to each other. And from that, we have to create the ER diagram, first of all, pictorial representation of it. And from that, we have to create the table. That means we have to convert the ER diagram to the relational database. So that is what our first experiment, and we will be considering all these things in this session. So let's start with the actual problem statement. Here we will be considering the problem statement as gradebook preparation for the Vidya. So it will be, we have to design an online grade book for the Vidyalanka to keep track and display the students' grade for several courses. Courses can be generated differentiated by the department, course number, semester, and the year. And knowing that the course title can be useful. For each class, the grade is determined by the grades of the various categories such as tests, quizzes, homework, labs, projects, etc. The percentage of the categories has to be equal to 100%, and the number of the assignments can vary. It may be 1, 2, or unspecified, and the instance that can be changed. Now, if I consider there are total 5 tests, as we have done the distribution of 50% marks for the test, 20% marks for the quizzes, 30% for the homework. If there are total 5 tests, then there will be only 10% weightage for each test. So combining 10 into 5, so total 50% weightage is given for the test. Then for assignment scores are stored on the point basis, and the assignment with the different numbers of the points in the same category are worth equally weight. So suppose there are 24% and there are 3 quizzes like 20, 50 and 100 points. Then the quiz will be 24.3 is 8% as the final grade. And the 4 quiz is added. If the 4 quiz is added, then the quiz is now 24 by 4 as 6% of the grade. Now here we need to, what is the problem statement is we have to design the list of the rosters for each class, including the name, student number, and the major of each class. We are requiring the change in the distribution. We will change in the distribution and we need the assignment, and depending on the assignment and distribution, we have to update the grades. So, along with that, we have to compute the average grade for each assignment, current percentage of the percentage score of each student, and then we have to sort the student's name and total percentage of the individual assignments. Now there are certain things we need to remember as every student be in more than one course. There may be more number of students for every course. Then since there will be many courses listed for the students, it is important it should not be duplicate information. The computed values, including average score, the final percentage, should not be stored in the database. So we have to design a database for all this to store the required data in this project. Now, what will be the probable solution for this? There will be a number of solutions available for it. I'll be considering one solution for it. So, first, the important point we need to remember that while designing the database, that for each table there should be one specific kind of the information, and the information should not be duplicated. From the description, it's very clear that we need to create the tables for the students and courses, but how we do not keep the track of the scores, enrollment, assignments, and the code distribution. Do we need do we need the tables for each of this? And so far, this information, this description, we need to find out. Now, for considering this description, we came to know that there will be two important tables which we need to consider. One is the student and second is the course. The student is the one entity which we will be considering for that. There are the parameters based on the student as first name, last name, and the student ID and major. So obviously that will be the different attributes which are there for the student. Now for the second table course, there will be department, course number, course name, semester, and the year. Attributes are there. So first we will be considering major two tables, student and courses. For that, whatever the required attributes are there, that we are listing it out. Now next is we have to have a table for the distribution, and for that, for the each course of it, we have to include the category and the percentage for it. Then along with that, we should have a table to store the details of each assignment, including the points possible and distance. So how many quizzes are there? Now the next task is we have to find out the relationship. Now for all these four different entities, how each and every entity is related to each other. That first of all we need to identify. Now, first of all, we are taking a course. A course can have zero or more students, and the students can be enrolled for zero or more courses. Now, a course will have one or more entries in the distribution table. There may be n number of the courses available. For every course, there will be a different distribution because there will be many different BSc activities are going to be there. Now, for every assignment must correspond to an entry from the distribution table, and each entry from the distribution table can have zero or more assignments associated with it. For every assignment, the scores varies from zero or more students. For each student can have scores recorded from zero or more assignments. Now, we have this complete information with us. Exactly what is the problem definition. From the problem definition, we identified that which are the main entities present in that. For every entity, what will be the different attributes associated with it, and how each and every entity is related to each other. That we are seeing now. All these things we have to put pictorially. That means first of all we need to create the ER diagram for modeling of it. Now, when we are starting with the ER diagram, as we assuming that you know all the notations of the ER diagram, we'll be considering that as for every entity, we are considering rectangle as a notation. So, student is the entity, and for the student entity, we have attributes as student ID, first name, last name, and the major. So, student is shown by the rectangle, whereas all these attributes are shown by the oval, and they are connected to the student entity, so that are shown by the links. So, considering this fact, similarly, there is another entity which is a course. For course, we have department, course number, course name, semester, and year attributes. So that are shown with the whole, courses is shown with the rectangle. Then the other two entities, which is distribution and assignment, that are even shown with the rectangle, and the related attribute to this is point possible. Instance number are shown with the oval, and they are linked with the assignment as well. Distribution is linked with the category and percentage. Now, the most important is how each and every entity is related to each other. When we are showing the relation of two entities, we are showing it with the diagonal. If now, how the student is related to the courses, first of all, as we have seen, there will be the course which have zero or more students, and the student can be enrolled for zero or more courses. So there will be many to many relations. So we are showing that for n number of the students, n number of the courses are available. Similarly, for n number of the students, n number of the assignments are going to be there. So many to many relation is there. Now for n number of the assignments will be there, and that will be distributed. So many to that will be distributed once. There will be only one percentage is there. So many to one relation is there. Whereas for one course there will be many distribution, many different assignment quizzes are there. So one to many relation is there. So that is clearly shown in the first part of the ER diagram. Now, when we are going further, we have to construct the draft for the ER modeling. That is recalling all the relationship and cardinality that we just have considered for it. Now, the next thing is we have to find out the primary key of each and every table. So primary key is nothing but the identifier of that particular entity. Now for students, student ID is going to be a primary key, so that we are showing by the underline. Similarly, for the courses, course ID is going to be primary key. For distribution, distribution ID is the primary key. For assignment, assignment ID is the primary key. So everything we are showing it with the underline. Now we have to add. It has been very clear that primary key is nothing but the unique identifier for that particular entity. Now next is we have to identify which are the entities which are weak, and the weak entity means that is dependent on the other entities. So here, for example, for an entry in the distribution has to correspond in the entry in the courses. So the distribution is weak. Similarly, entry in the assignment depend on the entry in the distribution. So assignment is weak. So finally, our ER is showing like this: assignment and distribution are the weak entities. Now, if we see the final ER diagram for this, so here all the relations, weak entity, then main entities, primary keys, and all other attributes have been shown clearly. So hence ER modeling has been complete. Now the next step is from the ER diagram we have to convert it into the relational. So for conversion of the entity to the relational, there are main 6 rules are available. So I'm not going into that rules, that we will consider into the next part. So first, uh, there will be a student entity. So for student entity, now we have to add the weak entities, including the attributes, adding as a foreign key, as a primary key with the dependency. In our cases, we have uh, distribution which dependent on the courses and assignment, and it depends on the distribution. So here arrows in the diagram indicates the foreign keys are drawn from. So here the primary key for the student is student ID, primary key for the courses is course ID. The next step is to involve the dealing with one-to-one and one-to-many relationship. We have none other than those default just have above. If we did, we should simply add the either table in one-to-one case or many to many a table in the primary key of the other table. That's why we are including the when we are considering the distribution table, since that is a weak entity, so the partial key of the distribution is distribution ID we are considering, whereas the course ID is the entity on which this distribution is dependent. So primary key of the courses is considered here as a foreign key. So total combined key of the distribution is distribution ID plus course ID. Lastly, we need to deal with the many-to-many relationship. Each of this involves the two tables. For each many-to-many relation, we add a new table with the new relative to both the tables that are related and include as a foreign key the primary key of the two related tables and make that the primary key of the new table. Also add the any attribute that are the part of the relation, and an attribute indicates order necessarily. Now we have two many-to-many relations. One is student and one is courses, and one between students and assignment. So there are two relations, which is nothing but enrollment and the student scores. So for former require there are no additional attributes, and latter requires the additional attributes to store the points. So that points will be considered in the given table below. So the final step is to convert the table. Here we are seeing the total 6 tables. Here the 4 are nothing but the main entities, and that we are converted into the table, whereas there are two different two relations which are even converted into the table. So total 6 tables we need to create for it. Now for further conversion of this table to the SQL, we will see into the next part of it with the Postgres SQL. Thank you.